Ladies and gentlemen, and welcome to GraphConnect, powered by Neo4j. Please welcome to the stage Emil Ephraim, CEO and co-founder.
In front of 1,000 people to the theme music of Star Wars. Check. Done. Off the bucket list. Awesome. Fantastic to be here. This right here, right now, is my favorite day of the entire year, the morning of GraphConnect. We have over 1,300 people registered for GraphConnect this year. Isn't that amazing? 1,300 people. So for those of you who are GraphConnect veterans, you know how we do this. For a couple of years, I didn't. Then I started getting angry tweets and angry mails and said, hey, what's going on? So back by popular demand is the GraphConnect, wait for it, morning gymnastics. So we're going to do this through a couple of questions. This is the 5th year of us running GraphConnect. The first one was in San Francisco in 2012. So I would like everyone who was at GraphConnect in San Francisco 2012 to please stand up. Few people. Awesome. Please remain standing. Anyone who was at GraphConnect in 2013, please stand up. Few more. All right, how about GraphConnect 2015? Please stand up. A little bit more. We have some veterans in the room. And then last year, GraphConnect 2016. Please stand up. So probably 50% is new. And then anyone who was at GraphConnect in New York 2017, please stand up and give yourselves a warm welcome applause. Fantastic. Feel free to sit down. If you want, you can do some light morning gymnastics. I'm not going to ask you to hug your neighbors or hand over your cell phone to the person right next to you or anything awkward like that. Cool. So my name is Emil Ephraim, and I'm one of the co-founders of the Neo4j project and the CEO of Neo4j Inc., the commercial company behind the project. I really only have one ground rule for all my talks, and that is that I do not want your undivided attention. I want you guys to test and trial and load challenge the Wi-Fi of this conference venue. Pull up your phone, use it, your laptops, use it. Tweet about this, Instagram about this, Snapchat about this, Facebook about this. The only thing that I do ask of you is that you use the GraphConnect hashtag or the Neo4j hashtag, because we monitor both of those very religiously. Cool. We have an exciting day ahead of us. I think the lineup for this year's GraphConnect is the strongest one we have ever had in terms of speakers and content. So I'm super excited. What we're going to do during this first hour or hour and a half is we're going to take a little bit of a step back, and we're going to talk about the state of the Graph Union, what is going on right now in the graph world, but much more importantly, where we see the graph world going in the future. So it's been a year since we had GraphConnect here in the US. A year ago, it was in San Francisco. But it's been quite an impactful year for graphs. There's been quite a few things happening. I'm going to tell you two particular stories that have unfolded since we last met. The first story is that of the Panama Papers, right, which was the biggest news story of 2016, or at least one of the biggest until Brexit and then the US election. There's a massive story, and its impact is seen already today, and even now, last week, for example. The Prime Minister of Pakistan was indicted over findings in the Panama Papers documents. So it's very relevant even today. And the heroes of this particular story is two journalists who work at a German newspaper called the Süddeutsche Zeitung out of Munich. And these guys were contacted by someone who offered to give them 2.6 terabytes of leaked data detailing supposedly the offshore tax haven bank accounts of the rich and the powerful. And offshore tax haven bank accounts can be used for legal tax planning purposes, but it could also supposedly be used for illegal tax evasion, right? So these journalists said, wow, that's a lot of data. Let's have a look at that. And they got this massive spaghetti ball of data that they managed to run through this open source pipeline of OCRing, and they had some ETL tooling in there and a bunch of things that finally culminated in 11.5 million identified documents and entities, emails, bank statements, scanned passports, like all kinds of things like that. Which, by the way, 11.5 million means that it was the largest leak in journalistic history. And they had to try to make sense of that, try to uncover newsworthy stories. They felt that there would be a lot of interesting information in there, but how do you go from 11.5 million documents to finding those stories? So taking a little bit of step back out of technology, just not talking about geekery for a while. In 1 minute, we're going to go all back into geek world. But in the world of investigative journalism, really what you want to do is you're looking for patterns, right? And here's an example of a pattern, right? You have a person. And that person is connected to, he has a bank account, right, with a bank. Not a very exciting pattern. True for me and for you and for all of us in this building, right? But it's a pattern. Let's build on this pattern. Let's say that this person lives at an address. At that address, another person lives. That person is an officer of a company which is registered with a bank in an offshore tax haven. All of a sudden, this pattern is a little bit more interesting, right? You can imagine, as an investigative journalist, you'd like to find those kinds of patterns in those 11.5 million documents. Now, of course, if you have those 11.5 million records just in a long table, it's very hard to uncover a pattern like that, right? Now, in the graph world, this is all conceptual, right? But in the graph world, we look at this, and we call these circles nodes, and we call the arrows between them relationships. And if you can attach properties to both these nodes and the relationships, all of a sudden you have a building blocks where you can model everything. This is what we call the property graph model. And with that, you can build any type of application. Right? Turns out that when you model your data with this data model, it leads to a lot of flexibility. You can very easily evolve your data as business requirements change, which, as we all know, they always do. You can query it at a really rapid pace, which, of course, is no challenge when you have 1, 2, 3, 4, 5, 6, 7 nodes. But what becomes really magical, if you wrap this data model in an infrastructure that supports not just these 7 nodes, but 1 million nodes, or 11.5 million nodes, or 1 billion nodes, or 10 billion nodes, right? So getting back to our story, that example is actually not a fictional example. This was exactly what ended up unfolding with the Prime Minister of Iceland, a gentleman by the name of Sigmundur Gunnlaugsson, who was not directly connected to a bank account in an offshore tax haven. Of course, if you're directly connected, there's no need to investigate that. That's obvious, right? But he was indirectly connected through his wife and his wife's company, etc. Right? He ended up being forced to resign over the findings in the Panama Papers. This was written up in every major newspaper in every major country in the world, and ultimately, the Panama Papers investigation actually won the Pulitzer Prize for this. Massive impact of being able to look at things that are not just directly connected, but indirectly connected. So that's my first story. My second story is in a completely different field. It's the field of healthcare. And in particular, it's around finding a cure for cancer, where graphs end up playing an important role right now. So finding a cure for cancer is obviously a very complex topic, right? You have a lot of moving parts. You have a bunch of different compounds. You have different samples of those compounds. You have individuals, their health history, their patient history, their medical use, what drugs they take, what dietary restrictions they have, etc. All of those things affect and influence each other. They're all connected in a way. So this is obviously, finding the cure for cancer is obviously a very connected, big problem. The challenge is that if you look inside of kind of the back door of all these big healthcare companies, they have they're stuck with legacy technology that is unable to work well with connections. So they have these primarily relational databases, which are good for many things, but finding connections then several hops out is not their forte. And not only that, they're stuck in disparate silos. So you kind of have a compounding effect of the base technology not being able to work well with connections, but then they also being spread out across silos, right? So the question is, what if you could take this data and put it in a graph database, and all of a sudden you can see how everything is directly and indirectly affecting everything else in real time. You can see that this particular sample trial affected this segment of the population in the following ways, right? I know today of more than 8 projects, independent projects, that use Neo4j to look for the cure of cancer. And I think one thing that unfortunately unifies all of us in this room is that you don't have to go very far to find someone that is impacted by cancer. If you're one step away, or at least 2 steps away, we all have someone who's impacted by cancer. And nothing makes me more proud than that we're being used in helping to find the cure for cancer. So the question then is, what is kind of the unifying story between the unifying pattern between these 2 stories, right? Well, it's that people had data, so that was good that they had the data, but they were really held back by their existing technologies, right? And there's a bunch of really good databases out there. I like Neo4j, not a huge spoiler surprise to anyone here. But there's a bunch of other really great databases. I've frequently been on the record saying that I'm a fan of the relational database. I think the relational database is one of the best pieces of computer science and the best pieces of engineering that I've ever seen. But there's also a lot of other good databases out there. We had our first IPO, database IPO in 20 years, just I think last week. Mongo went public, right? A document database. There's a bunch of other Cassandra, key value stores, there's document databases, all kinds of great technologies out there. I have one big challenge with them though. Fundamentally, they all have what I think of as a very simplistic approach to storing and working with data. I call this the store-retrieve model. Basically, you take the data that you have, you store that data, and then subsequently, if you're lucky, you're able to retrieve that data back out again, right? It's store the data, and then you retrieve it back out. With a graph database, we look at this a little bit differently. With a graph database, when you write your data into the graph, you attach that data to the rest of the world. And all of a sudden, the entire system gets enriched, right? So you take that data, you write it, and you attach it to the rest of the graph. And when you read that data back, you get context back, right? You get back everything that data is directly or indirectly connected to, right? And in that context, all of a sudden you find that fraudulent prime minister from Iceland, potentially, right? Or you find that cure for cancer, or in that context is the basis for your real-time recommendations, or your fraud detection if you're a financial services institution, or your identity and access management, and whatnot. We call this actionable insights, and it's a completely different level of ambition, I believe, in what we want to provide to you as end users of a database. We don't just want to be able to, you store exactly this, you get exactly that back. We want to give you more as end users of our database. Now, using connected data to get insights and through that build better products and through that gain a competitive advantage is not anything new. We've seen this play out before. A great example of this is in the consumer web, where at the turn of the century, here are some famous examples of companies at the turn of the century in the consumer web that were attacking a particular market, right? So you had the AltaVistas and the Lycos doing web search. You have Monster.com and whatnot doing jobs. You had a bunch of banks doing online payments, right? And they were all dominated by companies that leveraged connected data to build better products. The most stark example of this is probably Google, right? Where they did exactly the same thing as the AltaVistas and the Lycos and the Excite's of the world, right? Which means that they downloaded the entire web. When you had a query, they looked inside of every document and they tried to figure out whether that document was a good fit for that query result, right? That's what AltaVista, Google, all these guys did. Google did that. But on top of that, they also said, hey, I'm going to look at the context of this document. I'm going to map the connections. I'm going to traverse those connections, and I'm going to compute a score based on how many documents link to this particular document. Of course, that algorithm was famously called PageRank after one of the Google founders, Larry Page. And that was the basis, that one shift in perspective that connections in data are also as relevant and as valuable as the data itself. That one shift created one of the most significant companies, if not the most significant company of the previous decade. And really what we want to do at Neo4j is we want to take that power of connected data, put that in a very, very neat and convenient shrink-wrapped box, and give to everyone else. The Googles and the LinkedIns of the world have to invest hundreds of millions of dollars and I don't know how many person years into building an infrastructure that could manage connected data from scratch, right? And they took the time to do that, and they had the PhDs to do that, and they had the time and the dollars to do that, and they got rewarded for it. But we believe that there's a much simpler way. And for the next generation of companies who are doing that next journey, we want to be that back end. If you look just at some of these companies that ended up dominating their market in the consumer WAG, the top 6 companies if you add up the market cap of them, that's over $1 trillion worth of market capitalization. Right? So there's a lot of value in using these connections in data. So that's kind of the preamble. We've covered the basics. This is what a graph is. This is the impact it's had, and really the big picture around the massive business impact that you can get from using connected data. So let's talk a little bit about where we are as an industry today, the state of the graph union. A quote that those of you who got up very early and have been to several Neo4j events or have heard me speak, you've heard me use one particular quote probably more than anything else. And it's a quote by Forrester from 2014, where they sat down and they did some kind of analysis of the graph market, and they said that over 25% of the enterprise will be using graph databases by 2017. And when they said that in 2014, everyone thought they were crazy. And to be honest, I thought they were crazy too. I didn't say that, but I thought, like, wow, that's really ambitious. Like 1/4 of all enterprises will be using graphs by 2017. That's pretty astounding. And so I was preparing this presentation, and I was putting up my favorite quote, and I realized, wait, 2017 is right now. That's this year, right? So I thought it'd be appropriate to kind of have a look at how did that estimation hold up? Like, how good were they at reading the future? So looking at the graph space, what's been happening over the past few years, this is a site called DB Engines, which measures popularity or buzz about database systems. So they measure all kinds of signals like Google search results, tweets mentioning various projects, LinkedIn skill mentions, Indeed.com job posting, a bunch of things like that to compute a score, which really indicates popularity or buzz of a database system. And they also organize them per category. And graph databases have since 2013 been the fastest growing category in all of data, right? So that's pretty amazing. If you look just specifically at Neo4j, we see massive adoption along a wide variety of verticals. So these are some of our customers in financial services, which of course is very well represented here in New York, but also retail, consumer goods, etc. Right? We have today over 250 enterprises using us in production. And when you look at the community edition, over thousands tens of thousands even of projects that are running on Neo4j today. In fact, if you look at some of the biggest companies in the world, 7 of the top 10 retailers in the world now use Neo4j. 7 of the top 10. Right? Pretty amazing. Almost half of the top 25 financial services firms and 80% of the software vendors are using Neo4j in production today. So these are big companies, but what about small companies? 2 years ago, we launched a startup program here at, it was probably, I think it was in San Francisco, GraphConnect in San Francisco. We launched a startup program where we said that, hey, if you're a small company, you're able to get Neo4j Enterprise Edition for free or at a very reduced price, depending on how big your company is. And we have this startup program, and That was launched 2 years ago, and today we have over 500 startups in that startup program, which I think is pretty amazing. If you look at these logos, you may not recognize all of them, or maybe even any of them, but I bet at least one of them is going to grow into a household name based on this power of using connected data. And I think that is pretty amazing. So, in summary, Neo4j is a global, massive ecosystem today. There's over 10 million downloads now, if you count up since we got started. When we open sourced the first version of Neo4j back in 2007, version 0.7 or something like that, all the way up until now, it's over 10 million downloads of Neo4j. There are over 400 events every year around Neo4j. Think about that number, over 400. That's more than 2 per working day, right? Across the entire year. And of course, this is the biggest event of all of them, GraphConnect, right? Over 1,000 people. Many of these events, it's a small meetup with 20 people or 30 people or 50 people, right? But this is not organized by us. Sure, the big one is organized by us, and I don't know, maybe 100 of these 400 or 200 maybe. Maximum 200 of these are organized by us. The rest is a super passionate girl in Jakarta who just loves our stuff and organizes a meetup around that because she just wants to talk about anything new about Neo4j, right? Or there's a guy in Tokyo who just loves thinking about what graphs can do in any industry and organizes a meetup around that. That's pretty astounding, I think. We have over 250 plus customers, as I mentioned, and there's a global meetup community of over 50,000 people today. So getting back to that quote then, so how are we doing, right? Forrester predicted over 50%. Well, good timing, because just a few weeks ago, 3 weeks ago, they launched their recent report about the graph space, where they had a bunch of analysis of different vendors and this and that and trend and whatnot. But they also surveyed over 2,200 enterprises to ask them about whether they're using graph databases, what they're using them for, or do they plan to use graph databases and things like that. And they concluded that over 50% of enterprises are actually using graph databases today. Isn't that absolutely amazing? So that crazy prediction that they had, that even and I'm relentlessly bullish on graphs, right? Even I thought like, wow, that's pretty steep. They were actually lowballing it. It ended up being twice that. So I think that is pretty amazing. Cool. So when I kind of reflect on these accomplishments by our customers over the past several years, I think back. I mentioned 2007 as the year when we first released the first open source version. It was like a 0 point something, so very, very raw and immature. But it's really been 10 years that we've been at this. And I remember some of the first conversations that I had with investors when I said that we want to build a product that is like the Oracle database, but with a new data model, right? A data model that is not going to replace the relational database or anything like that, but we believe that it's optimized for this increasingly connected future, right? And that vision has been our lighthouse for this decade, right? And here to tell you about what's the next step towards that vision, which is Neo4j 3.3, is none other than Philip Rathley, Neo4j Head of Product. Philip.
Improvements to the Cypher runtime engine. And the second is a new kind of index that has much more efficient write characteristics for numeric properties. Let's start with the first. And I'd like to show you 3 query examples to illustrate the kinds of gains that are possible. In Neo4j 3.2, we focused on making simple queries better. In 3.3, you'll see that some more complex queries, these are all reasonably complex queries, run significantly faster depending on the query. Not only that, but the memory footprint for queries is significantly diminished, which will help you squeeze more performance out of less hardware. Now let's talk about write performance. We have a lot of tests that run internally and crank away. And one of our load tests tries to simulate real-world transactional writes. And you can see if you go back 2 years, over the last 4 releases, performance of this particular test, along with a bunch of others, has improved significantly. And 3.3 is no exception. If you multiply these out, transactional write performance has improved 700% in the last 2 years, and that's a lot of progress. Let's next turn to security and operations. In spring, we introduced a new multi-data center clustering feature. We have configurable groups, tiered replicas, and the ability to really, with a lot of granularity, control your cluster, give it a lot of self-awareness so that you can manage it across multiple availability zones, multiple clusters, multiple data centers. A lot of you who are running across multiple data centers have pointed out that you'd like Neo4j to handle the encryption of data between data centers so that you don't need to set up a VPN yourselves and manage lots of third-party infrastructure. And I'm pleased to say that in Neo4j 3.3 we've done this. Neo4j 3.3 now comes with intra-cluster encryption. Conveniently, this uses the same certificate management infrastructure that's already in place for managing encryption from client to the database via TLS via Bolt. Finally, we've made some productivity improvements, primarily in the area of drivers. So let's talk about those. There's a new 1.5 version of drivers that goes hand in hand with Neo4j 3.3. Some of the improvements are introduction of an async programming model, support for byte arrays, and a new kind of load balancing called least connected load balancing that works hand in hand through bolts down to the cluster to make sure that you're balancing load efficiently across your entire cluster. In addition to that, we've made improvements in 2 other parts of the Java stack. And there's a Neo4j object-to-graph mapper that sits on top of the Java driver. And on top of that, you have Spring Data Neo4j. Recently, there was a major release of Spring Data. And we're pleased to, in alignment with that release a new version of Spring Data Neo4j that includes lots of new features. So it inherits all the benefits of the new drivers, as well as supporting user-specified IDs and ID strategies, dynamic properties. There are significant additions for clustering that handles all multi-DC quite transparently, supports causal consistency, bookmarks in a way that's transparent for end users. There's a well-defined strategy for retries, lots of other improvements here. So really happy with this new spring release. There are also some performance improvements here. There's finer grained mapping for improved performance and efficiency across the board. So we hope you'll enjoy this. We hope you'll enjoy this new release. We think you will. I'm really happy to speak about it today. And with that, I'm going to hand it back to our fearless leader.
Awesome. Thanks. Cool. Excited? I'm pretty excited about Neo4j 3.3. So this vision that I talked about before, about building like a database, a real database, transactions, durability, persistence, etc., but with the new data model has really been our guidepost since 2007, right? To build the best graph database on the planet. And I think Neo4j 3.3 is the best graph database on the planet today. And we worked really hard on that for a decade, right? And we've come really far, but when I talk to customers, I see myself on screen, on stage. This is probably not what's supposed to happen. This is one of those meta recursive things. But when I talk to my customers, and we frequently are out and we see how you guys use Neo4j, we see that there's a lot of work left to be done, right? What we see as a huge surprise to absolutely no one is that Neo4j very seldomly is deployed in isolation. We live in an ecosystem, of course. There's a relational database, and you move data in and out from that relational database to Neo4j. There's a data lake and legacy data warehouse, or and more modern big data, Hadoop, Spark type environment, right? And move data in outside of that, etc. And so what we've said to ourselves is that, well, so how can we make it even easier for our customers to get started with all this, right? And make it more frictionless to build graph-powered applications. And that has made us think a lot about what's next in graphs. What about the next few years in graphs? What if you could simply get all of these technologies in one cohesive package, right? What if you could start with an amazing database like Neo4j, right, which could do graph transactions in real time, right? But then on top of that, what if you had a very powerful and rich analytics library on top of that, which comes with a built-in set of graph algorithms, right? You could run them at massive scale. And what if you had a set of technologies that made it really easy to move data in and out of your graph system, right? To integrate with your relational database, with your other NoSQL databases maybe, with your data lakes, with your data warehouses. And what if you had rich and sophisticated tooling to enable both data scientists and data analysts as well as developers to work more powerfully with that connected data? And what if you had a toolkit that would allow you to expose this to business end users in a code-free navigation type way that enables both visualization and discovery for those users, and a rich and consistent and unified powerful API to all of this, right? This architecture is this, or variants of this, we see in almost all of our customer projects. People build up something like this. And our goal is to take that and put that in one cohesive, well-integrated package and offer that to you end users. And we call this the Graph Platform. And I believe that this is the future of graph technology. And I'm super excited to tell you a little bit more what we're doing in this world. I think of it a little bit like the LAMP stack for the web, right? As the web rose to prominence in the 90s, the LAMP stack emerged as kind of the default way, at least the default starting point to use to build web applications. This should be the same level of cohesive, well-integrated package, a one-stop shop for everything connected data, right? We believe that this is the future of graphs, and we're going to be completely focused on building out this in the future. But much like the perfect graph database wasn't available when we got started in 2007, the entire graph platform isn't available today. However, here to give you a little bit of a sneak peek, a sneak preview of the future, and show you a little bit of a demo of this graph platform is none other than my colleague, Ryan Boyd. Ryan, please take the stage.
Thank you, Emil. I am going to show you today how the Acme Payment Network, like some of the top payment networks in the world, uses graphs to power their business. Acme Payment Network uses each and every part of the graph platform. They use the data integration tools in order to load data from their legacy relational databases into Neo4j graph database, the core of the graph platform. They also use the discovery and analytics tools, the discovery and visualization tools to explore their graphs to understand what is happening in the network. And they use the analytics, the graph analytics, in order to speed up the determination of fraud and money laundering activity. So I'm going to switch over now to the demo, and I'm going to show you how all of this works together as part of the Neo4j graph platform. So what you see here is the Neo4j desktop. The Neo4j desktop is the control center, the mission control for the graph platform. At the top here, you see a number of apps that we've built. We call these graph apps. And some of these graph apps are actually coming from Neo4j, such as the Neo4j browser and the ETL tool. Other of these apps, such as Acme Dash, Acme Viz, and Acme Algo, are actually built by the Acme Payment Network. So first, I'm going to jump into the Neo4j ETL tool. And the Neo4j ETL tool allows us to bring information in from those relational databases that they store the transaction information in. We go over here and we can set up a relational database connection just using JDBC. I've actually already set up this connection, so I'm not going to type all these things in here, but you can use Postgres or MySQL, or with the Enterprise Edition, also use Oracle to pull data in. And then you go over here to import data. And we're going to click on that connection that we've set up, and we're going to say Start Mapping. Now, what this has done is it's connected to our Postgres database in this case, and it has looked at all of the tables in the schema of the database and mapped those tables into a property graph model. It has used the primary keys and foreign key relationships in order to do this mapping, and we can see here our property graph that was created. So we have an account. I'll try to see if I can make that a little bit bigger for you. We have an account which sends money to other accounts, and we have a person. Now, this relationship between account and person isn't exactly what we want. We actually want the relationship to be owned by, so we're going to modify it over here, and we can see the graph on the right-hand side has been updated. So we're going to map the account table and the person table into nodes, and you can see the corresponding relationships. You can also go and modify the different the different properties of the nodes and relationships here, and show how those are going to be mapped. So now I'm going to import my data here, and it takes just a second to import the data from the relational database. And then I'm going to hop over back to the mission control, the Neo4j desktop. And I'm going to use a tool which you all know and hopefully love, which is the Neo4j browser. Now, the Neo4j browser has always been one of the key components of the Neo4j database, and it is the developer tool. So as the developer tool, I can see here what labels and relationship types I have, and I can write our Cypher queries. So in this case, I'm going to write a Cypher query here that is just going to look at the transactions, or the first 50 transactions, from account 1 to account 2, and look at the amount of those transactions. And so we get these tabular results showing account 1, account 2, and then the amount of the value of the transaction, which is all good and dandy, but I needed to know Cypher for this. And now all of you probably know Cypher, or many of you at least. The IT administrator who would do this loading from the relational database over into Neo4j probably knows Cypher. The developer does as well. But what if we're the fraud analyst? If we're trying to detect fraud and money laundering activity in the payment network, the fraud analyst might not know Cypher. And while they could certainly learn Cypher, they might want a better way to do their exploration of the graph. So with that, I'm going to actually hop over to Acme Viz here, a visualization app that we built to look at the payment network. And I'm going to start by searching. Let's say we're interested in an account owned by Tom. I'm going to search for Tom. And oh, wait, it wasn't actually Tom. Tom must be a nickname. We have here an account Tamika. And if I double click on this, we can see Tamika is a person. And we can expand Tamika here, and we can see the account that Tamika owns. And we can see here the account number there. And if we look at this account and look at the relationships from this account, we can see all of the transactions that are occurring in that account. Now, we see the transactions. If you look at the relationships here, these are all money transfer transactions. And you can see money coming to the account owned by Tamika, as well as leaving from that account. And if we look at one of these particular places that Tamika is sending money to, we can expand that node as well. and we see a person named Tomar is who Tamika is sending money to. So this is great. As a fraud analyst, I can explore the network in a visual way. It is great for ad hoc exploration, discovery. But what if I want to be a little bit smarter about this? What if I want to provide the fraud analyst the power to speed up the discovery of fraud or money laundering in the network? So for that, I'm going to show you how we might apply graph algorithms or graph analytics in order to do that. So if we hop over here, I have this Acme Algo app, and I'll show you the queries it's executing. This Acme Algo app is really just executing a few simple Cypher queries. The first one is union find. This is a clustering algorithm to determine the different communities in the graph. These are people that are transacting often with each other, sending money often to each other in smaller groups. I'm going to add some labels so we can see what those communities look like. And then I'm going to also run a centrality score so we can see the important actors in the network, the people who a lot of these money transfers are going through. Now, I just wrote this simple application here to call these Cypher functions. For those geeks in the crowd, I will show you what that looks like. We are actually just calling a couple procedures in the algorithms library. The first one here is calling the union find procedure, passing in a virtual graph to that procedure. And then we're labeling the nodes and running the closest centrality algorithm here. Okay, so we've run these algorithms. Now let's jump back to the discovery and visualization tool, or the discovery and visualization graph app, and see how those algorithms have helped us speed up our results here. So instead of searching for Tom here, what I'm going to do is search for account that sends money to, account. And notice I'm not using Cypher here. It is looking at the labels and relationships in my database to do this. And I'm going to find all of the transactions in the database. So we see all of the transactions come in, all of the places where an account is sending money to another account. And what you see up here in the top right are the different labels in the database here. And so we have cluster 1 through 5. These are the community detection algorithm results that are clustering the current transactions, the transactions that we are of interest to us today. These are the transactions that have occurred recently. And we see laundering targets. These are the ones with high centrality scores, the ones that are kind of the information gateways in the network, or in this case, money gateways in the network. So now if we zoom in here, we can actually see the different clusters. In this cluster, we see a couple different red nodes here, those laundering targets. We zoom in a little bit further, and we can see actually it's identifying the types of nodes we have here. The orange nodes here are in cluster 2 and their actual bank accounts. And then we have our potential criminal, at least, right here. Now, this was determined by that centrality algorithm to be someone that really shares a lot of transactions with different groups in the network. And you can see how that works here. You can actually see just by dragging around this node how many people within the network or how many other connections and groups within the network that this particular account is transacting with. So now let's look at this account. So we have that account. We have a lot of these relationships incoming. We have a lot of money that is coming into this account. And we can also see that there's a lot of money going out to this account, to one other account here. So let's look at each of these relationships. I'm going to double click them, and we can see the amount of the transaction, in this case, $9,526. And if we look at each of these others, we will actually notice $9,215, all right below the $10,000 US reporting limit. So we can see that this potential laundering target has transacted and sent a lot of money right below that limit. And now if we look at who it is sending money to, or the account it's sending money to, and hit expand here to find information out about that account, well, it is sending all of its money to me. I'm excited, I'm gonna be rich, this is fantastic. Only I also have a bunch of relationships going out. Why am I giving my money away? Let's see here how much money I'm giving away. If I double click on this, I'm giving away almost $100,000 or 10x that reporting limit. And I have a number of those transactions. So it looks like I'm giving away all of my wealth. So we're going to see here who I'm giving that wealth to. And I'm giving it to Emil. It's going a little bit the wrong direction here. I work for Emil. He should be giving the money to me, not the other way around. But anyway, so we've investigated here and showed how a fraud analyst might use the power of the discovery and visualization tools, as well as the power of graph algorithms and graph analytics as part of the Neo4j graph platform in order to speed up the discovery of fraud and money laundering. Now, this is how the analyst doing the business every single day might use the graph platform. I'm going to show you one other graph app here, though. And this one other graph app here is a dashboard. It is a dashboard for the executives of the company, maybe like the chief risk officer of Acme Payment Network, to use to just keep an eye on the status of the network. So this is a custom-written application using JavaScript in this case in order to understand more about the network. Payments that are occurring by cluster, outgoing payments over time, incoming payments over time, a lot of interesting data so that the executives can really see what the total amount of risk is with these potential laundering targets. Now, this isn't just any old application. This application is actually powered by a newer technology. It is powered by GraphQL. GraphQL is an alternative for building APIs. It's an alternative to REST, which is commonly used today. And this application is built using what we call the Grand Stack, or GraphQL, React, Apollo, and the Neo4j database. You can find out more information about the Grand Stack at grandstack.io. We see this as something that is really going to revolutionize the way that we build applications, powering your graph-based applications with the GraphQL framework. So with that, I'm going to invite Emil back onto the stage here, and he's going to talk a little bit more about the platform.
All right, I am relying to the 1,000 or so of you to keep me honest here, but oh my God, wasn't that like the most amazing demo ever? Seriously? I don't know, I'm drinking maybe too much of my Kool-Aid, but that was just awesome, right? I could watch that demo all day. In fact, I feel like I have watched that demo all day over the past couple of days, but it's still awesome. So I'm super excited about being able to build out this platform to make it easy for everyone in this room to build applications like that. right? We're going to be working towards this over the next few years. And some of these things we're going to build ourselves. Most of this we're going to build ourselves. But some of it we're going to use third-party technologies and integrate that into the platform. For example, on the visualization side, we have a strong partnership with a great tool called Linkurious, right? But our promise to you is that whenever it's in the platform, it's going to be well integrated, it's going to be robust and tested, and it's going to have a great experience out of the box. So this was the glimpse of the future, right? The question then is, what of this is available today? So all of it isn't available today, but also none of it isn't available today, right? So let's dive into that. First off, the stuff that Philip talked about, Neo4j 3.3, is available today on neo4j.com to download. So please go to neo4j.com and download the latest release of Neo4j 3.3. The other thing that is available right now is the Neo4j desktop application that Ryan showed you. This is what ultimately is going to be kind of the mission control for the entire Graph platform with these Graph apps on top of it that you saw in the demo. It'll start out, however, as the developer's best friend. This is a great way for you to manage your local Neo4j project. It'll remember what dependencies you have, what various tools and technologies you have tied to your different projects. It'll automatically update your software for you, manage old versions, and all those good things. I think this one is going to be super, super powerful already today, and even more so going forward. Another thing that we're including in Neo4j Desktop is we're doing a little bit of a tweak to our licensing, where we now include in the Neo4j Desktop, Neo4j Enterprise Edition with all the bells and whistles that is included for free for individual developers. And I think that is really cool, so that you can, on your local box, you can run Neo4j Enterprise Edition, $0, no cost at all. And in preview is the tool that I think you hopefully picked up from the demo. That was the beginning of the demo, so it was a while ago, but where Ryan pointed the Neo4j ETL tool to a relational database, got the schema, could look at that, saw the graph representation of that, and then click, you've imported that data into Neo4j. That's an early preview release, but very, very exciting. And then finally, last but very much not least, is the first release of Neo4j Graph Analytics. And I'm super excited about this one. This has 3 core family of algorithms. It has centrality, pathfinding, and community detection. Centrality is helps you find the influential, maybe the most valuable, or at least the most connected nodes in your graph. So for example, it can help you find influencers in your telco network, as one example. Pathfinding is, of course, going to point A to point B. It can help you guide your autonomous vehicle from going from New York to Boston, right, or something like that. And community detection is, one example of that is what Ryan showed in his demo. You can find clusters of potentially fraudulent transactions, right? So all of this is now included out of the box with very rich, powerful, and highly performant algorithms. So Neo4j started out on the purely transactional side. That's where we started, right? So if you grab onto a specific node, we can traverse really fast from there. But when you wanted to do graph global algorithms, then sometimes a better choice was an existing analytics framework like Spark, for example. Spark, of course, has one pillar called GraphX, where you can run graph algorithms, right? That world is rapidly changing. Neo4j is rapidly becoming really, really awesome for those types of graph analytics operations. Here's an example of where we run 2 algorithms compared to Spark cluster on equivalent hardware, where Neo4j is anywhere from 60 to over 200% faster than Spark with Neo4j analytics out of the box. So all this is available right now, so you should go to neo4j.com/download and